Hi, everyone, and welcome to Beyond the Map Tiles, a new limited podcast series between the IEEE, Geoscience and Remote Sensing Society, or GRSS as it's better known, and Project Geospatial. I'm Ryan Lewis, a partner with SRI Ventures and an industry outreach volunteer with GRSS. As listeners of this show know, the geospatial industry has experienced a wave of innovations in the last 10 years. GRSS-related research, a technical society under the IEEE umbrella since 1961, has played an important role in some of these innovations. This limited series seeks to highlight some of those, as well as current trends in our industry. Specifically, each episode in this series will address a new part of the map stack. At the bottom layer, the collection of novel data types. In the middle, the development of new data management and analysis platforms. And at the top, the deployment of new analytic applications. In today's episode, we'll be focusing on the second part of the map stack, the development of new data management platforms.
To help us unpack everything that's happening in the middle of that stack, I'm excited to welcome Mo Sarwat to the show. He is the CEO and co-founder of Wherobots, associate professor of computer sciences at Arizona State University, and the co-architect of the Apache Sedona project, formerly known as Geospatial. Mo, welcome to the show.
Thanks, Ryan. Thanks for having me.
Right. So Mo, just on the introduction alone, right, there's a lot to unpack there. And I'm really excited that you're the first guest on our show today, because I think you and your personal journey, as well as the journey with Wherobots, highlight exactly some of the trends and things that are happening in the geospatial industry today that we want to feature on the show, on this limited series. So why don't we kind of start from the beginning with you before we get into kind of what you're currently working on with Wherobots, right? Kind of start to me with just your role within the research community in the geospatial field. Like, looking back at some of your publications, this is an area you focus. How did you get started in this area, and what really got you passionate about geospatial research?
It all started. Like again, my education, my bachelor's is in computer engineering. So it's not that, like, again, it's not that far. But what I learned at the university was mostly programming, computer engineering, computer architecture, all that kind of stuff. So I actually very well grounded when it comes to these kind of topics, like computer architecture, specific topics. And actually, it's before going to grad school, I worked as a software engineer right out of college. And when I was a software engineer, I didn't work in the geospatial domain. I worked actually in the electronic design automation domain before going to grad school. So I was building some of these CAD tools that help you design chips, microchips, build the software behind it. I know it's like very far, but I remember back then, we were developing the system to index the chip architecture on a 2D plane, the CAD design itself of the chip architecture, and we're using a quad tree back then. So it was very related to what spatial is.
Yeah.
It is, yeah. So it's not that far, it's not geo, but it definitely has a lot of spatial, because again, the design is in 2D or 3D, and you do a lot of spatial analytics on the chip design itself. But it wasn't before grad school that I started to pay more attention to geospatial. Actually, a little bit before. So I worked as part of a startup as well on mobile advertising, and we were doing a lot of work where how can you deliver advertising to mobile phones, and that was before the iPhones and all that kind of stuff. So also a lot of geospatial kind of challenges there, and building the data platform to deliver these advertisements actually was a little bit of a pain in the butt from a scalability perspective, and also from a data management perspective. Fast forward to grad school. Yeah. So grad school, I did my master PhD also in computer science at the University of Minnesota. And this is where I joined the data management lab at the University of Minnesota. And the main focus of the lab is basically data management research, but for spatial and spatial temporal applications for the most part. So this is where it started, and that was in 2009. And I got my PhD in 2014, and that was my focus. The focus of my dissertation is, again, broadly speaking, is like data management, large scale data management, robust data systems for spatial and spatial temporal applications.
What's kind of interesting too is like when you look like most things, when you look in retrospect, they seem obvious, right? But when you're in the moment, they're not as much. And looking at just some of your early papers, right, and having read some of them myself during my early days at Cosmic Works, right? Like you have been trying to tackle different parts of the data management problem for geospatial for since your entire time in grad school. And I was looking at some of your award-winning papers from IEEE that go back to 2012, and it kind of makes the eventual launch of GeoSpark like it seemed like an eventuality, but it wasn't. Especially for somebody who's contributed to open source, it's a big lift. And what prompted you post some of these award-winning papers in the 2015 post time period to say, we need to do something more?
So first, I mean, in the midst of my PhD, this is where there was a big revolution happening in the data management domain. Remember, it's like the Obama administration was back then kind of pushing towards big data, and for a reason. It's not just a political reason. It's just it was the whole world was just waiting for new platforms that can unravel like kind of the secrets and the insights in that data for business value, right? Societal and business value. So the big data wave came in while I was in grad school, and I was back in the time I was working. One of the projects I was working on in grad school, it was actually related to machine learning for spatial. So building more specifically recommendation, building location-aware recommendation applications, and how can you use like these machine learning based recommendation algorithms, but to recommend places to go and recommend things based on the customer location. Obviously, this is mainstream now, but back in the time, we were one of the first people that actually started working on that kind of the piece of work. And one of the main challenges was how can you build that huge kind of analytics kind of stack on top of the spatial data? And we had access to data that was collected from location-based social networks back in the time, data collected from Yelp-like applications, right? And it was not that big. It was just a few gigabytes. And still, building that whole stack on top of it was quite the pain. Pain in
Not
terms of
trivial.
managing
Not
it.
trivial.
Yeah.
We take it for granted
Yeah.
now.
Absolutely, yeah. So it was huge, yeah. So back in the time, so I thought about like how can we build something alongside in the same lab at the university. Was my a colleague of mine was working on a project that enables Hadoop to understand spatial data. And I really liked the project, even though it was not my project. So I looked at it, and that was his kind of thesis topic. And he did a really, really great work with that. And I saw how much impact you can have by having that uh, massive, massively scalable data platform. You can enable a lot of applications that you could not have been able to do with just the de facto data platforms back in the time. And I'm talking about de facto here. There are multiple of them back in the time, and still they are active now and they're used. Like, for example, you had Postgres, PostGIS, you had Oracle Spatial, you had a few other open source, even like GIS companies had their own data platforms internally, like Esri and others as well. And again, these are great. All of these are great efforts, right? And great companies and great systems, but they were not designed for that scale. They were not designed for even the workload. That size of the data, volume of the data. Again, remember the three V's of big data: variety and velocity. They were not designed for all of that, right? So that's why
And veracity. Don't forget veracity.
and veracity. Yeah. So it's very mature, these kind of things now, these kind of terminology, right? So they were not designed for any of that. So that's why the effort of extending something like Hadoop was actually very, very good. And I found a lot of value. However, I'll be completely honest, back in the time, given also my training in data management and data platforms, I was not a big fan of Hadoop per se. I was a big fan of the shift in that direction, or the movement into that direction. And Hadoop was like step zero, I believe so, in that direction. I was not a big fan of the architecture of Hadoop. It was still like not as good. It also has a lot. I don't want to go into details of this because I still appreciate Hadoop too much, and it helped us reach the point that we are now. So back in the time, Apache Spark was starting up, and I mean, early on, being part of the data management community, seeing the publications early on, even before Spark got really popular. After that, I read the science behind it. I listened to the talks by the original authors, and being in academia in pretty much the same community, I saw value in that, and I realized, you know what, I want to be able to see how we can use that to solve spatial problems. So the first thing I did is that, like, okay, I mean, when I first started as assistant professor at the university, I said, you know what, I'm going to look at Spark. I'm going to take some of the spatial problems that typical spatial problems people work on, and let's see how we can port them into Spark, and realize that Spark is scalable, but it's actually was not very well optimized for spatial workloads. In other
Give,
words, it will.
for those that maybe haven't like had to launch, right, like their own instance before, and they're maybe more business or more end users of these sorts of technologies. Give an example of like uh, uh, an example workload that you were testing through Spark and kind of seeing essentially where it broke.
Yeah, something that most people in the spatial community have encountered before. It's very simple, very basic example, but it's actually very prominent, very popular. Is spatial join. So you have a bunch of polygons, right, representing, let's say, the cities in the entire U.S. And you have a bunch of GPS tracks also moving around the city, and you want to just join the two data set together. You want to find all the GPS tracks within every single kind of polygon that represent the city. Or these polygons can be even more complex. It can be moving polygons representing different areas or anything like this, or variable. So it's a very simple operation, yet it's very useful, and it's every single spatial application use it, pretty much, right? Data from various sources, you want to integrate them together, you have to do spatial join. Obviously, it's a very data intensive application, and for spatial applications also can be a little compute intensive because of the geometries of the polygons. So taking that, what we did is that we started, you know what, we took two data set, we load them into Apache Spark back in the time, and we started doing spatial join, the logic of spatial join, like again, for each polygon, find each point. If the point lies within the GPS trace, lies within the polygon, that's one result. It's a check, right? And you keep doing that. If it doesn't, you just drop that, and that's the outcome of the spatial join for the most part. So very simple, and Spark is very scalable. So it's scaled, but it didn't take into account the spatial characteristics of the data. And in other words, it missed on opportunities to optimize the data stack for that very operation. And what I mean by this is that it used more CPU resources, more memory resources, and more network bandwidth within, if you have a cluster machine to do that at scale, right? Let's say you have AWS nodes to run the Spark cluster in, and you spend also a lot of money on that because it's a lot more resources. So we realized that with Spark. So even though it scales, it will get you the result. It's not going to freeze like existing systems. Like if you did that on the large scale data back in the time, and even now with PostGIS, it will take forever, and sometimes it might actually not even continue, right? Not give you the result. And not to mention, if you do that with existing GIS kind of applications, this is I mean, even now, right? You have to connect to more scalable data platform to be able to do that, right? And that's what some of these GIS platforms are trying to do now, which is an effort I support personally. But yeah, so we tried to do that. So we thought about this problem then is like, okay, how can we make that compute engine, Spark, understand spatial, utilize resources in a more economic way, in the fastest way, And instead of give you the spatial drawing result in 10 hours, give it to you in half an hour. That will reduce time to market. If you're even a researcher or a scientist in the lab, it will give you an opportunity to have a smaller cluster with cheaper resources to be able to run your experiments. So it's not just business value, also a lot of societal value and scientific value as well, if you can do all of that. Um,
Yeah,
plus, yeah,
and it's not surprising that this took off, right? So when you guys launched GeoSpark, I mean, I remember myself living through it, right, and having some of the teams that I was part of were actively using it. So, but how quick did you see some of the growth, right, from the launch
exactly.
of the
So
project?
we launched, we had this problem and we developed a prototype of the system that solved this problem again. The speed, the scalability, the it makes Spark understand spatial very well. And the API as well is like we wanted to make the API for the spatial developer to be an API they're familiar with. So if you've been using, for example, PostGIS, you pretty much use the same spatial SQL that you used in PostGIS, except that it's going to be more scalable and way faster and runs in the cloud very easily, right? So this is basically what we provided. We put a honestly, I mean, we did this in the lab. We definitely thought this is a big deal, but when we submitted the prototype to GitHub, uploaded that to GitHub, we thought maybe 5, 10 people will find it useful
Yeah,
and start using the software. And a lot of academics do that every day, by the way. So we publish a paper and we publish the code online, and maybe 5, 10 people will like kind of want to, for example, repeat the experiments. They will use that code base to repeat the experiments and enhance the research and do whatever. So this is what we thought in the beginning. But something crazy happened is like we were not realizing that the market was in needed that. The market was in a position now that people were fed up with the existing stack, and they wanted to push for something that is not just more scalable and faster, but something that also seamlessly integrated with with the cloud. So everybody was moving into the cloud. Still, not everybody's in the cloud today still, but like there's a huge shift in the cloud that happened, I would say, after 2015, something like this. There had been a huge shift to the cloud. So everybody was moving there. So he wanted something easy to use, integrated in the cloud, integrated within their data stack. I don't need to have like a legacy GIS platform
yeah,
downloaded on my desktop to be able to do something like this. And it's still not as scalable. I just want to do this as part of my data pipeline, right? And this is why, I mean, it has received a lot of traction. And instead of 5, 10 people just using it, we've been seeing thousands of downloads. And fast forward to today, today we have 1.1 million downloads on a monthly basis for the software
that's
for the
insane.
package. So it's definitely we're happy with this. We're very proud of it, and we can't wait to even like push more in that direction, right?
No, you just it is a classic example of right. You're the project hit at a key time, right, where you had, to your point, a lot of organizations moving right to cloud infrastructure. So being a lot more open and flexible to try new projects and new architectures. At the same time, you had a lot of new data sets coming online, right? I mean, I know just to speak for myself, almost take for granted now some of the open data that's just available in the geospatial community alone. Going back to 2014, 2015, that was not the case, right? And third, right, you have a much greater variety of geospatial applications, right, that we now leverage through our phones, right? Back then, some of those are still pretty novel. Um, and so it's kind of funny that you were hitting all of it at the right time. And I think, kind of given all that popularity, it's cool. I think it particularly jumps out to me that, you are kind of constantly looking ahead, right? So you started this open source project, gains a lot of traction. you get, as of 2020, you're brought into the Apache Foundation, but still ever looking forward, in last year in 2022, something sparked in your head to say, well, we need to do something more than just this project, right? To fill a need in the market for customers that, you've obviously either worked directly with or indirectly through your open source efforts. So what really prompted the idea to go beyond the open source effort and start something like Wherobots?
That's actually a great question. So I'm as like through our talk today, you probably may have like noticed that like I'm pretty much an academic. So I went through the academic route.
Really?
I stayed
I didn't know.
I stayed in school for so long, right? So for me, it's like even though I worked in the industry, but I did a lot of schooling, like all masters through PhD. Even after that, I'm gonna be a professor. I stayed in school too. I went to become a professor. I also got tenured. So it's just like I went through the whole process of academic vetting as well. The reason I started Wherobots, like there are various reasons. Uh, One reason is I saw the impact that the software had on so many businesses, on so many kind of. I saw the societal impact as well. So people using Sedona have used it in businesses like logistics, delivery, insurance, automotive, but there are also people using it for businesses that have related to climate, again, climate change, carbon credit calculation, and all that kind of stuff. Also, other people are using it for in the World Bank. There is a team that is using Sedona. So there are so many use cases that has a huge impact on the day-to-day life of every single person living, I mean, in this planet, on this planet. And it's actually very refreshing to me. I saw the impact firsthand, and I thought, how can we amplify this impact and democratize it to every single um business, every single even societal project that can have a lot, like again, that have this impact be 10 or 100x than even it is right today. So that is the reason. And I, when I thought about this, I thought you can just go too far with just being an academic with a couple students working on the project. But if you have like a business entity that you can grow and it can push that vision forward, you can achieve a lot more. So this is one reason, definitely, actually, that kind of pushed me to start the business, to start Whereabouts. And that is actually, I mean, believe it or not, I mean, that is the number one motivation. Other motivations or other reasons that
Well,
you,
I
yeah,
think, Mo, and I
please.
believe that, right? Because, momentum begets more momentum, right? So I don't think there's, right, a single person that's contributed, right, to an open source project or, any other sort of open initiative. And as that builds momentum, that builds feedback, right? I am certain that over the years, you started getting not only ideas, but probably a high volume of requests, all from users that were leveraging Geospark, then renamed Sedona once it became part of the Apache Foundation. And that probably created a long list of ideas of going like, man, I wish I had a mechanism, right, to service that. But I can't. I don't have any tooling at my fingertips. So I suspect, right, when you were first thinking about this, you probably had a couple of applications top of mind or problems that you wanted to attack, right, with the launch of Whereabouts.
With the launch of Whereabouts, we like a few things. So there are many businesses, or quite a few software startups that were based on open source that we can actually learn from. So early on, like maybe 20, like between 20 and 30 years ago, was mostly about operating systems, the open source operating system for the closed source. And you have the Red Hat model and how they came about having some share in that market, and which they did. They did a great job, in my opinion. But there are also the models, the newer models that we can follow. So, uh, example of that at Databricks, for instance, as a company. So Databricks started with open source Apache Spark. Now they're definitely not positioning themselves as like the necessarily Spark is the only thing we offer, right? But it started that way, and it has gained the traction that way. That
Yeah,
said,
now it's almost the de facto solution for most organizations doing some type of AI ML project. I know in sort of my prior lives, very rarely, right, was Databricks not part of the architecture in some capacity.
absolutely, they did a great job. So I mean, I'm a big fan of. Uh, Again, I'm a big fan of the founders of Databricks. I'm a big fan of their vision and whatever they achieved technologically. So it's definitely something to look up to for sure. And so this is kind of the pretty much the model that we want to follow. However, we have to take in we have to take anybody who's coming into Wherobots as we're speaking today and want to work with us or partner with us are pretty much someone who used Sedona already and understand the value of it,
Yeah.
which is great. So we have a good like kind of head start. I mean, because of that as a company. So a lot of companies don't have that. A lot of people have to do sales from 0 to 100, right? I mean, we don't start from zero. We say we start from 10 and we want to reach 100, which is good. That's a good head start. However, there are still definitely challenges when it comes to spatial compared to just traditional data stack. And these challenges are not necessarily related to technology per se. It's mostly related to culture. So, and that's something that I
What,
can,
what
and
would
I,
be an example of that?
for instance, I mean, the spatial community is very large, right? Um, I mean, people, I mean, the culture is have been highly impacted by the traditional desktop GIS based kind of applications and all that kind of. So when you talk about like when you think about spatial, uh, you think about that, or a lot of people in the market would think about that. This is not necessarily a bad thing. I mean, I think the GIS, these desktop GIS applications have made a huge impact on the market, and I also value them a lot. Example of that is Esri, definitely a great company, right? I mean, made a huge impact on the field, on everything related to geospatial for like 4 decades now, even more. But the culture needs to change in a sense that you think about problems from a data platform perspective instead of a GIS perspective. This change is happening, and this is not going to cancel GIS as GIS tools or anything. Actually, au contraire, it's going to make them even more popular, bring more business to them. But the idea of adopting a spatial or geospatial strategy in the enterprise is not going to fly if we keep the technical culture within our community, the spatial community, just focused on the GIS tool itself. You have to be more data centric, more data platform centric, as opposed to GIS centric. In other words, it's okay, accept the reality. It's like a lot of people will not accept the reality of space and time as attributes of the data are really important attributes, but they're not the only attributes. So
Yeah.
there are a lot of other attributes that are also important, right? And then space and time is important, as well as other attributes that are existing, and they can have a huge impact. That separation between spatial and the rest of other aspects of the data platform, this is what created the that culture divide that I was talking about, and it's changing now. So people in the spatial community are realizing this, and they're realizing that we don't work in silos, right? I mean, I'm not gonna. Yes, I wanna, because I'm working spatial. I want to feel like spatial is the most important thing ever, and you should. I mean, you should be treated as a first class citizen in the data platform. But on the other hand, it shouldn't be used as, or shouldn't be treated as the only citizen in that data platform, right? So this is basically the culture, and it's shifting now. So this is I'm seeing that shifting as we're speaking today.
And it's interesting you bring that up because I remember, this is going back, to when some of the first more AI based either projects or applications were coming online. It was very much data science was described kind of in one bucket. GIS, spatial analysis was in another, and the two really didn't cross, right? Or that there were very clear lines. And I think particularly right as you have spatial analysis either be a core component of products or applications or the only component of certain products, right? It forces, right, that merger together, which is where I think products, right, such as yours, right, are potentially filling a really important gap, right? So within the company, right, you launched last year, you have pulled together some initial financing from venture capital. Kind of in the next couple of months here, what can we, for those that are interested that have maybe already been using Sedona or at least familiar with it, what gaps are you looking at with Wherobots initial product release?
Uh, Thanks for asking that. So basically, I mean, if you look at the current spectrum of data platforms, right? And I'm talking about all these cloud native data platforms, all the way from the ones provided by the major public clouds like AWS, and Azure, and GCP, all the way down to the something like Snowflake and Databricks, as well as others that are similar, but these are the most popular ones. They're great data platforms, very scalable, cloud native, and some of them provide serverless functionality. Uh, it enables people to do a lot of the data, kind of port their whole data stack to the cloud, which is fantastic. I'm a big, like, I support that, and I support more of that. However, if you look at all of them, almost all of them, they support. If you ask them, do support spatial, they will say yes, right? Which is great. But you look at the reality is that you end up looking at whatever they support in spatial, and they support like 10% of what spatial functionality is needed by the application. That leaves the developer or the engineer or the data team with nothing but implementing the rest of the 90% on their own. So you will have, let's say, your database in Snowflake or in Databricks. You use the 10% spatial functionality support, which is great, but the rest of the 90% you implement on your own on top of these platforms. So you build your own spatial data stack for the most part, 90% of it your own. Is this possible? It is completely possible, but the problem is that that will cost millions and millions of dollars to build, a lot of time to build, and a lot of manpower to build too.
A lot
Big
of
companies,
organizations just don't have that. I mean,
exactly, and
this would be
some people did
perfectly
it.
one.
Most organizations don't have access to that, and the organizations that manage to do it is something similar to, let's say, Uber. Uber has a great spatial data infrastructure, right? They managed to build that, but it took them hundreds of millions of dollars and a lot of engineers to build that over years.
So,
Uh,
so what do
so
you so what do you have coming up? And what
what
should
we are
folks in the
providing,
industry be on the lookout for?
we're bringing the whole spatial data stack, the spatial data infrastructure that is scalable, robust, secure, and integrated with the cloud. We're democratizing this. We're bringing it to the enterprise so that all spatial compute and AI technology that you will need in your application, we'll bring it to you easily incorporated in your decision-making applications, uh, easily integrated with your data, whether this data, whatever the modality of the data is, structured, unstructured, semi-structured, and could be deployed anywhere. What I mean by this, could be deployed on any of the major public clouds seamlessly. So this is what we are providing. So think of Wherobots as the enabler. It provides the spatial data infrastructure for the creative teams to build their own spatial applications on top of it. We're providing the building blocks to do that. They don't have to worry about engineering that data infrastructure. It's already done on their behalf. They just have to call the spatial functionality and build their the next generation climate tech app or ag tech app, or build the next generation delivery or logistics app, whatever it is. So this is why our branding focusing on working with these creative people and enable them to do great things with the spatial data infrastructure we provided them.
Well, that's very cool. And will you have a beta list that people can sign up for?
We are actually we're going to provide a beta version of what we call the Wherobots spatial compute and AI engine. That's a 1.0 kind of version, and we will be releasing a link for people to sign up for the for beta test. And it's going to be fully integrated. It's going to provide no code integration with Databricks. If you, for example, your data is in a lake house and stored in Databricks, and also with AWS, if your data is in S3, for example, and you want to use AWS instances to just deploy, we provide this no code deployment. We're going to provide also like more spatial data modeling and indexing method like H3 out of the box as well, very highly optimized. And we're going to provide a library for spatial machine learning. So all supervised and unsupervised classic spatial machine learning training algorithms will be available out of the box with that to train on your own data in the enterprise, as well as like a library to handle maps data. If you want to do map matching, if you want to integrate your data with OpenStreetMap, with other kind of map data sources, run geocoding, reverse geocoding, all of that as a service out of the box with that kind of spatial compute and AI engine. And again, deployed in your own cloud infrastructure so that it runs within your own cloud, it runs at scale without worrying about the details of engineering that.
Well, that's super cool. I'm excited to see it when it comes out. And kind of to conclude, right, Mo, as someone that has been both a researcher in this domain for years, a founder and contributor to open source projects, as well as a founder of a tech startup. So what advice would you have for researchers that are either just getting started in this field or maybe thinking about jumping into a startup or some sort of open source effort, from just based on all of your experiences over the years?
Ryan, even though I'm not the best person to give advice, but I'm going to try, right? So one thing that, I mean, it worked out for me at least is what we call like focus on practical system-oriented research. A lot of people, like researchers in their early years, they focus a lot on the difficulty of the problem more than the practical side of the problem. So the first question I would ask myself before working on any problem is this actually a problem, right? I mean, or is it's just like a beautiful math that I want to work on to show that I'm very smart? The solution can be very simple, by the way, which is actually easier solutions or simple solutions are way better than difficult solutions. But the question is more important than the answer, in my opinion. So if you're asking the right question, and the right question is definitely a problem that it's an important problem. It's a practical problem. It's gonna, people before and after asking that question, it's gonna change. Like, I mean, the whole trend, the whole kind of area is gonna be impacted by just asking the question. So this is one thing that worked out for me, and this is what I live by myself. That's number one thing. As it comes to when it comes to being a startup founder, there are a lot of many times you'll be tempted by a lot of things as a founder. For instance, you'll be tempted to, for example, raise money from people you don't want to work with, or people that are not gonna, they're actually gonna negatively impact the business and the vision of the product and all that kind of stuff. This is one thing I learned, is that I learned to say no. And that doesn't mean that being snobbish. In fact, I appreciate people that I work with. I appreciate VCs that I work with, and I'm very, very thankful to their support. But the main reason we chose to work with these with someone, or we chose to partner with them, is not because they're going to provide the money for the most. That's one reason, but the biggest reason is they're going to help us help push the business, push the vision, push the product. This is number one thing. Another thing that people will be tempted, especially a startup founder, is buzzwords. Uh, People are tempted. There are a lot of startup founders. I don't necessarily blame them all the time, especially if they're early stage. There is a buzzword
It's
these
hard not to
days.
fall into the trap, though.
Yes, you have
Hard
to.
not to fall into it.
Like these days, for example, of like GPT and Chat GPT, right? I see a lot of people are kind of, since it's a hype, so everybody's trying just to follow the hype. Is that good or bad? In my opinion, ChatGPT is a great technology, for instance, and I support it, and I think it's going to make a huge impact on our lives, and even positive impact. I know a lot of people have their own kind of they're a little bit reserved about, but I think it has. But what I see is like people just follow the hype without thinking of impactful application to the user. So one thing is to avoid following that hype. People are gonna eventually appreciate when you are actually solving a real problem they have. It doesn't matter. So, and your business, if your business is not solving a problem to the customers, you're never, no matter how buzzwordy you are, right? If you follow every single hype and every single buzzword and keep telling that, yes, I do that, I do this without substance, nobody's gonna, your business is never gonna thrive. You can stay for a few years, but you're never gonna make an impact on this world. So this is another thing I'm reminding myself not to fall into that trap of just following buzzwords without having substance. You need to have substance and something you can provide for the customers, for the world, real contribution.
Well, I know how busy you are, both with starting a company as well as everything else you're doing within the community. So I really appreciate you taking time today and talking us through some of this really important area that's unfolding in geospatial, and wish you and the whole your whole company the best of luck.
Thanks a lot, Ryan. I really appreciate that you're having me on the podcast and being the first one on the podcast. I really enjoyed my time. I'm looking forward to interacting with the community a little more, and hopefully I'll be able to attend GRSS this year to even meet people in person.
Absolutely. Well, everyone, thanks for listening to today's show. You can find links to GRSS, their upcoming iGuys conference, Wherobots homepage, and the Apache Sedona homepage in today's show notes. Stay tuned for upcoming episodes with the GRSS limited series hosted on Project Geospatial. Thanks again.